I wanted to make a quick video just showing all of the transformations on one single page. So I'm just going to quickly go through the 3 different types of transformations and an example for each of them from 3.4. So for these examples, we're using the parent function of the absolute value of x. So I've just written in a graph and then I've put the absolute value of x in each example. And then I'll write over how this would change the graph. Okay, so let's first just outline what the 3 different types of transformations are. So we have shifts, we have compressions or stretches, and then we have reflections. So a shift just means that I'm going to take that exact graph and move it. So it's a parallel line. It's just not in the exact same place it was before. So those are examples of shifts. A compression or a stretch would just be making this graph narrower or wider on the horizontal axis or taller or shorter on the vertical axis. So you could do something like that. You could do something like that. Those are 2 compressions. You could also stretch. Or you could stretch. So those would be examples of stretches. And then reflection just means you're taking either all of your x values and making them negative or the opposite, or taking all of your y values and making them the inverse of the original. So this would be the inverse y values. These would be the inverse x values of this equation, which is probably the square root of x. All right, so let's start with shifts. Again, shift is just moving it up or down. So we have vertical shifts on the y, horizontal shifts on the x-axis. Good. Okay, so I'm going to start by just writing what a shift up will look like. They're always addition and subtraction, whereas a compression down here, the compression is always going to be multiplication or division, or like it's multiplication or it's the multiplication up by a fraction. Good, which is the same as division. Okay, so y equals the absolute value of x plus 3. So if this was the correct graph of the absolute value of x, how would adding 3 outside of the grouping symbol of the absolute value bars change it, right? Basically, you're taking the function f of x and you're adding 3. So whatever the function was, you're adding 3 to it. Good. Here, you're doing that same thing, except now you're subtracting 3. Whereas here, they are horizontal shifts, so you're going to be moving left or right, and it is f of x minus 3. So that's the difference. If we just want to look at the difference really quick. Before, sorry, that's a plus 3. That's a minus 3. So that's the difference in how you would see the original graph and the addition or subtraction. If it's on the vertical, it's outside of the grouping symbols. If it's horizontal, it's within the grouping symbol. All right, so in fact, our f of x, our parent function, is the absolute value of x. It could also be, for example, y equals the square root of x plus 3, or y equals x squared plus 3. Those are other ways you could write it. Okay, So adding 3 moves it up on the y-axis. 1, 2, 3. So instead of 0, 0, my starting point, my origin is 3, or sorry, the lowest point is 3, 3. And then I just go up 1 over 1, up 1 over 1. So it's that same graph, 3 higher. Again, if I'm going down, we're following the same pattern. So instead of up 3, I'm going down 3 on the y-axis, up 1 over 1, up 1 over 1, and so on. So once you finish this, you'll be able to just quickly look at, okay, if I'm subtracting 3 outside of the grouping symbols, I move down, right? Remember, the horizontal shifts or the shifts within the grouping symbols are the opposite of what you intuit. Okay, so if we're adding the 3, we're not going to the right on the x-axis, we're actually going to the left on the x-axis. So instead of starting at 0, 0, we would start at -3, 0. But our graph would look the same. We just moved it along the x-axis. X minus 3, we moved it this direction on the x-axis, the opposite direction. I'm sorry, I gave you examples for that one, but I didn't give you examples for the rest of them. They might be self-explanatory. So you could do the square root of x minus 3. You could do x squared minus 3. Here you could do y equals, and the difference would be that this is x plus 3 all under the radical. For x squared, it would be parentheses x plus 3 squared. The whole quantity is squared. Same here, except we have a minus. Good. Okay. So for compressions or stretches, we saw what they looked like a little bit down here, right? You're actually making something wider, narrower, taller, or shorter. Vertically, you are pulling or shrinking in the y direction. And remember, what you do is you take that integer and you multiply all of your y values by that integer. So if you had y equals 2 times the absolute value of x, first I'm just going to write the model of it. So this would be 2 times f of x. So it's very clear that the 2 is outside. Here we have y equals 1/2 f of x. But here, y equals 1/2 x, we have y equals y equals f times x over 2. Good. Here we have y equals f to x. All right, so vertical, it's as you would expect. Stretching it by 2, by a whole number, will make it twice as tall, right? So instead of 1, 1, it's going to be 1, 2. It'll still start at the origin. So it's not a shift. It's the origin is not moving, but the shape of the graph will change. Very good at losing all of this. Good. So it's twice as tall. 1/2 is going to make it half as tall. So instead of 1, 1, we have 1, 1/2. Good. All right, and then we have horizontal pulling or stretching. Pulling or shrinking in the X direction, which is left to right. So you're either making it wider or you're making it narrower. Here we made it shorter, here we made it taller. Now we're gonna make it wider or we're gonna make it narrower. Good. So here, if we are multiplying X by 1/2, instead of 1, 1, we have 2, 1. So we have made it wider. And then 2x actually makes it narrower. So now the 1, 1 is now 1/2, 1. The reflections are pretty quick. So if the negative sign is outside of the grouping symbol, you're reflecting it on the x-axis. So all the y values of this graph become the opposite or negative. And then if the negative sign is within the grouping symbols, inside of the grouping symbols, you're reflecting it on the y-axis, which means all of the x values become the opposite of what they were. And it is the same on, it mirrors itself on the y-axis. So basically, I just want you to be able to see this is, so the parent function here would be the square root of x, right? If the parent function has a negative sign in front of it, do this. If the negative sign is within the grouping symbol, do this. If you see something like this, it's going to look like this. If you see something like this, it's going to look like this. Okay, this is just a guide so that you know how to quickly tell what this looks like as a graph. Thanks, guys.